Hello everyone, welcome to the third video of 2.2 bonding between atoms. We'll be covering ionic bonding property and also the structure that causes the properties. Slide wise, we are looking at slide 17 onwards, and we'll be looking at first and third box in this table. So firstly, valence electrons are transferred from a metallic atom to a non-metallic atom to form ions. Ionic bonding is the force of attraction between the oppositely charged ions. What you need to be able to do is to predict the charge on the monoatomic ion formed by an element using its position in the periodic table, and also to be able to write the electron configuration using subshell notation. It was covered in topic 1, so if you have forgotten how to do that, make sure you can do that. Yep. And the third box down there, the properties of ionic compounds can be explained using the model for ionic bonding. So again, you need to be able to draw a model, and using that, you need to be able to explain the melting and boiling points and electrical conductivities of ionic compounds at different state, that is. All right, let's look into what ionic bonding is to start with. Now, this diagram there, or the GIF image, it's showing that ionic bonding occurs between positively charged and negatively charged ions, between metal atoms and non-metal ions, to be exact. Metal atoms lose one or more electrons depending on the position on the periodic table, and bonds to non-metals atoms accepting that electron, and both of them will be full. Both of them will have a full valence shell. Yep, that's what you call as electron transfer. We'll be doing role play of how this can occur in class. Okay, the definition of ions, let's look at that. So ions are atoms which have lost or gained electrons, and as a result have an overall electrostatic charge, positive or negative. Now this definition would only apply to an element becoming an ion, not the polyatomic ion. Okay. Polyatomic means it's got many atoms within a group of ion. An atom loses one or more electrons, that you would call them as positively charged ion, and if an atom gains one or more electrons, you would call them negatively charged electron. Gaining something negative electron would make an atom negative. Ionic bonding occurs due to the electrostatic, which means permanent charge attraction between the ions involved. All right, ions of metals and non-metals, I think it's been covered as well, but positively charged ions are called cations. So what would make cations? Usually metals, because they want to lose their electrons. Cation. So sodium plus, Na plus, or magnesium ion, which is Mg2 plus, would be an example. Negatively charged ions are, on the other hand, called anion. They are the negatively charged ones, and what gains an electron? Usually non-metals. So non-metals usually form anions, like Cl minus or O2 minus.
You've got two of them.
Yeah. So let's look at why metals and non-metals lose or gain electrons. So you need to be able to gain the understanding first. Let's look at that. Firstly, everything wants to be stable. Reactive metals that you'd know, like sodium metal, why would they want to be reactive? Because after reaction, it will be stable. Atoms are more stable or unreactive when they have full amount of electrons in outermost shell. We call that configuration as the octet configuration, if you have remember that. So that actually means that when element atoms have noble gas-like electron configuration, you know that noble gases are the most inert, chemically inert, unreactive, non-reactive elements, right? So if a metal lose electron or non-metals gain electron, they gain the octet. All right. Atoms of elements will lose or gain electron in order to get the full outer shell. So, and also atoms of elements do this by reacting with other substances. That's what happens to, okay, metals. They would have very low valence compared to the rest of the periodic table, +1 to +3. That's what they would form. Now, that means that they would have lower electronegativities. If you have forgotten about the definition of it, look it up again. They hold onto the outer shell electrons with a weaker force. The electrons are easily lost and achieve the octet configuration by losing them. Just like you, as a boy, having a, I don't know, handbag. Maybe you want to lose it. You don't have much attraction towards it. Or imagine this. Sorry about that. Imagine this. Imagine this shoe rack with only 2 shoes there. It's easier to probably make it empty to achieve the octet, the most stable configuration, because 2 in the big row seems to be a bit off. Whereas non-metals, they have high valencies, +5 to +7. So they want to gain electron to become +8. They have strong attraction towards electrons, so higher electron negativities. Like Cl, they want to gain 1. They're eager to do that. They hold on to outer shell electrons with a strong force, and extra electrons can be gained to the outermost shell very, very easily. Now, so picture that I have there is a shoe rack, I suppose. Oops, not that one. Shoe rack. It's incomplete. I don't know what girls feel about that. Then maybe girls want to complete it by buying 2 more pairs of shoes. So, non-metals are a bit like that. I'm not being sexist, I know. All right, what happens to group 4 or group 8? So noble gases. So group 4 elements, they have got valence of +4, which is halfway to be 8, but it's a bit hard to achieve that. Losing 4 electrons or gaining 4 electrons, it's equally hard. So what do? They don't form ions. They share those electrons and they're happy about that. Okay? So that's what group 4 elements would do. And that's why carbons can be found in any organic, and silicons can be found in inorganic substances. All right, and group 8, they already have full octet configuration, so they don't want to do anything with the electrons. They don't want to lose or gain, so they don't form ions too. Yep. This is an extension, I guess, explanation, which you may have seen in year 10. So all the elements that I'm showing there already have, I'll zoom in, have got the electron configuration written. Like group 1 elements, all of them have got 1 as outer shell electron number or valence, 2 to 2, 3 to 3, and so on. From the position of the periodic table, you can guess what sort of number of electrons will be transferred, either gained or lost. Group 1 would lose 1 electron and form a +1 ion. That trend goes up to 3 for group 3. Group 4, as we said, it's Na. They don't form ions. Group 5 is closer to 8. So instead of losing 5, they would rather gain 3 electrons. And that would form 8, the octet configuration. Therefore, nitrogen atom will become nitride ion, and nitride ion would have -3 as its charge. And that trend goes down. Trend is going down, so -3, -1, -2, -1. Sorry, number decreases, but in a positive, negative direction, positive direction. Group 8 would be Na. Exception would be hydrogen. Normally, nonmetals gain electron, but because it's in group 1, having only one electron in its outermost shell, it wants to lose that electron to be just proton. Noble gases already full. Oh, already said that, didn't we? There will be a school or exercise that you can do, so we'll do that in class too. Okay, I'll stop here. So wait for the next video, please. See you then.